Good morning. Welcome to Strategic Saturdays by DARS Academy. I am Miss Joseph, your facilitator for today, and we are covering finding inverse functions. So your introduction to inverse functions. First, the definition: an inverse function undo what the original function does. The notation: if f of x is a function, its inverse is written as f to the negative 1 of x. Graphical representation: the inverse functions are reflections over the line y equals x. Importance: inverse functions help solve equations and model real-world situations. Now, here are the steps to find the inverse function. First, replace f of x with y. Then, swap x and y. After that, we will solve the equation for y, and then replace y with f to the negative 1 of x. Now let's look at an example using these steps. So we're going to find the inverse of f of x equals to 2x plus 3. So first, we're going to change f of x to y. So now we have y equals to 2x plus 3. Next, we will swap the x and y. Now, x equal to 2y plus 3. And now we will solve for y, or make y our subject. So in this instance, we subtract 3 from both sides. Now we're left with x minus 3 equals to 2y. Then we will divide both sides by 2, and that leaves us with x minus 3 divided by 2, and that equals to y. Now that we have solved for y, we will replace y for f to the negative 1 of x. And our inverse is f to the negative 1 of x equals to x minus 3 divided by 2. I hope that helps. Now let's look at a quadratic function. We're going to find the inverse of f of x equals to x squared minus 4 for when x is greater than or equal to 0. So first, we're going to replace our f of x with y. So now y equals to x squared minus 4. Then we are going to swap our x and y. So now x equals to y squared minus 4. Now we're going to solve for our y, making our y the subject. So in this case, we added 4 to both sides, and we're given x plus 4 equals to y squared. Then in order to remove the square, we must take the square root of both sides. And in the end, we are looking at the square root of x plus 4 equals to y. Now we will replace our y with f to the negative 1 of x. Now f to the negative 1 of x equals to the square root of x plus 4. Now in this instance, because it's a quadratic function, we must restrict our domain in order to ensure a one-to-one function. Now let's find the inverse of a rational function. In this case, we have f of x equals to 2x plus 1 divided by x minus 3. Our very first step, we are going to replace f of x with y. So now y equals to 2x plus 1 divided by x minus 3. Now before we swap our x and y, let's simplify this rational function first. In order to do that, we will multiply x minus 3, which is in the denominator, on both sides. And here's our result. We have y in parentheses x minus 3 equals to 2x plus 1. Now we're ready to swap our x and y. So x times, in parentheses, y minus 3 equals to 2y plus 1. Our next step is we're trying to have y as our subject, or solve for y. So before we do that, let's remove our parentheses by distributive property. What I mean by that, I am going to multiply x times y and x times negative 3. Now we have xy minus 3x equals to 2y plus 1. Now as we solve this equation for y, we are going to move the 3x over to the right side, and we're going to move the 2y over to the left side, resulting in xy minus 2y equals to 3x plus 1. Now on the left side of the equation, I notice that y is common to both terms. So I'm going to factor out the y. Once I factor out the y, I'm left remaining x minus 2 in the parentheses. On the right side, it remains the same. It's still 3x plus 1. Now I'm ready to make y my subject. I will divide both sides by x minus 2. So now y equals to 3x plus 1 divided by x minus 2. We're not done yet. We still have to replace our y with f to the negative 1 of x, which represents inverse. So now we're done. F to the negative 1 of x equals to 3x plus 1 divided by x minus 2.